Okay, Year 12. So here are the answers to those multiple choice questions. Standard molar entropy is 0.4. Well, as I've said many times, you have zero entropy at 0 Kelvin, and 93% of you getting that right. Anything other than absolute zero, than atoms, elements, molecules, are going to have some entropy because there's some disorder. And remember those graphs from my lessons. Standard molar entropy of a substance is 0.4, perfect crystals at absolute zero. Hammering that home, and not surprisingly, over here, equal number or even higher number, 95% of you got that right. Question 3, the molar entropy of a perfect crystal is 0 at absolute zero. Apologies for hammering this home, but hopefully by that third question, even those of you who are starting to get it wrong are now realizing that absolute zero is no entropy. Which of the following is the correct order of decreasing entropy? So the highest entropy, well, it's certainly not going to be ice at 0, so it's going to be steam at 100 degrees C because it's going to be gas. Then it's going to be liquid, and then finally it's going to be a solid. So gas, liquid, solid, decreasing entropy, and 98% of you got that right, so well done there. Butane has a higher standard molar entropy than 2-methylpropane at 298 K in 1 atmosphere. Both compounds are gases. The best explanation is, well, if butane had a higher boiling temperature, it is more likely to be a liquid, and therefore it would have a lower entropy, so it's not that one. A more positive standard molar enthalpy change of formation. Well, entropy is not really anything to do with enthalpy. Fewer ways of distributing the energy quanta. Well, if butane has fewer ways of distributing the energy quanta, then that means it would have a lower entropy. So it must be D, the fact that there's more vibration modes, translation modes, rotation modes available to butane. And there we go, 83% of you getting that right. When a gas jar containing pure oxygen is inverted over a gas jar containing pure nitrogen, the gases mix spontaneously. You know this, the gases will just naturally mix. Why is that? Well, it's not that oxygen is denser than nitrogen. If that was the only driving factor, then you'd end up with oxygen sitting at the bottom and nitrogen sitting on top. It's nothing to do with the standard molar entropy of oxygen or nitrogen either. The reason they mix is that the mixing of the gases increases the entropy of the system. And go back to that idea of the Smarties tube from the very first lesson. Why do those Smarties mix spontaneously? Well, it's just that there's more ways to intersperse the oxygen and nitrogen gas molecules than there are to have the oxygen in one part of the system and the nitrogen in the other part of the system. And again, 83% of you getting that right. There's a decrease in entropy of the system when a gaseous molecule decomposes into two smaller gaseous molecules. No, two smaller molecules, more ways of arranging them, so that would increase the entropy. A solid decomposing to form a gas. No, again, gas has far more entropy than a solid. A solid melting. No, a liquid has far more ways of arranging those particles than a solid does. But when a vapour condenses, going gas to liquid, there are far fewer options for where you can put those particles, because instead of being all through the atmosphere, they're constrained on a surface or in a container. So yes, 100% of you getting that one right. When solid sodium hydrogen carbonate is added to dilute hydrochloric acid, the mixture starts fizzing and the temperature drops. Which statement about this reaction is not true? Well, delta H is positive. Yes, that means endothermic. So the temperature would drop, so that is true. if that is true, then that is sucking in energy from the surroundings into the system. So the temperature of the surroundings goes down, and therefore it has less energy and less entropy. So that is not true. Definitely B is not true. The entropy change of the system is positive. Well, actually, we're generating a gas, so we know that that is true. And delta S total is positive. Well, it's spontaneous, so that must be true. So therefore, the one that's false is B. And under 80% of you here, but over 3/4 of you getting that right. In which of the following reactions is there a decrease in entropy of the system? So we're looking for anything where gases are being destroyed, like this one. We're losing a gas. So that's a contender. This one, solid going to solid and a liquid. No, that would be an increase in entropy. This one, we're generating a gas, so no, that would be an increase in entropy. And this one, we're generating a gas, so no, that would be an increase in entropy of the system. So it must be A. And yeah, 95% of you got that right. Consider the following reactions in the gas phase. What is the order of increasing standard entropy change for these reactions? Okay, so this you're going from 4 gas molecules to 2 gas molecules. So that would be a large decrease. So that's the most negative. Is F. This one you're going from 4.5 gas molecules to 5 gas molecules, so that would be a small increase. And this one here you're going from 3 gas molecules, in fact, why don't I write this, 3 gas molecules to 3 gas molecules, so that would be about 0. And this one, as we said, 4.5 up to 5. So it should go F, G, H, A from most negative through about 0 to positive, and yes, over 3/4 of you getting that right. The signs of delta H reaction, delta S system for 4 different gases are shown below. Which reaction must be thermodynamically feasible at all temperatures? This is a good question. And you can either think about it from the point of view of delta S total or from delta G. So let's look at delta S surroundings. Well, if it's a negative delta H, that means it's exothermic, so the surroundings gain energy, and that is positive. So those two would be positive. But if it's a positive delta H reaction, that means it's endothermic. It sucks in energy from the surroundings, which would lose temperature, and so that would be a negative change in entropy for the surroundings. So negative, negative, delta S universe is negative, so that is never feasible. But positive, positive here, delta S universe is always going to be positive, so that is always feasible. The other way we could have looked at it is delta G equals delta H minus T delta S. And if we want this to be negative, because of course delta G is negative in a spontaneous reaction, we want that to be negative, and we want T delta S, so we want the delta S to be a positive value, so that bit's negative and that bit's negative, so negative, positive, negative, positive, B again. So both cases would point you to the fact that B is the one that is always feasible. And 70% of you getting that right, over 2/3, but still a large proportion of you can't work these ones through, and they do come up a lot. Sodium chloride dissolves in water, but it's endothermic. The best explanation for the fact it's spontaneous, nothing to do with the low activation energy. This is all about the speed of the reaction, not the feasibility. Positive enthalpy change, no, that if anything that hinders the reaction. Positive entropy change of the surroundings, no, absolutely not, because the surroundings are losing energy, so they have a negative entropy change. But the thing that drives it must be the large positive entropy change of the system, a solid becoming mobile ions, D. And yes, although not many of you actually getting that, less than 2/3 of you getting that right. Which is correct for standard molar entropy? Right. First thing to realise is that iron is a solid. So the lowest entropy out of these is definitely going to be iron, so it's A or C. Out of H2 versus nitrogen, this is much bigger. And so therefore it's going to have far more entropy. So the highest entropy would be nitrogen, followed by hydrogen, followed by iron, C. So, oh wow, look at that. Many of you getting that wrong there. So just under half of you getting that right. So pay attention to that, okay? It's the size of the atoms that's important if you're comparing gases. Right, answer the question with a cross in the box. Oxidation of sulfur dioxide is a reaction in the manufacture of sulfuric acid. What are the signs of the entropy change of the system and the entropy change of the surroundings for this reaction? Well, the system is going from 3 to 2 gas molecules, so that is a decrease in entropy. So delta S system is negative, so it's going to be C or D. The entropy change of the surroundings, right, is exothermic. So delta S surroundings would be positive. So it should be C. And yes, almost 3/4 for you getting that right. Still 1/4 of you not getting that right, which is worrying, but there we go. What are the signs of the entropy changes at 273 Kelvin when water freezes? So water freezing, okay, delta S system is clearly going to decrease because you're going from a liquid to a solid. So it's going to be a negative delta S system. Water freezing must release energy. Freezing is an exothermic process. And if it's exothermic, that means the surroundings have a positive enthalpy change. So the answer is A. Again, only 50% of you getting that right. Happily, at least you guys are realising that the system is losing energy. But guys, come on, you know energy is put in to melt something and to boil something. And you should know from year 7 physics that freezing and condensing release energy. This is why a burn from steam is so much worse than a burn from water, because as the steam's condensing, it's releasing energy into your skin. Ethanol burns in excess oxygen to produce carbon dioxide and water. Standard molar entropies. Calculate delta S system. Should not have presented a problem to you. 2 times 214 plus 3 times H2O, 70. And over here we've got 161 plus 3 times 205. So it's this number minus this number. Okay, so let's do this very, very roughly. That is about, what, 400 and 210. So that is about 600 minus, what's that? That's about 600, 750. So the answer is about 600 minus 750. So we're looking for an answer of about minus 150. A, there you go. And this is just showing that you don't actually need a calculator if you can do just rough estimates like that. So minus 138, hopefully A. And yeah, 93% of you getting that right. So glad to see you can do the numerical ones. Nitrogen reacts with hydrogen to form ammonia. What is the value of delta S surroundings at 25 degrees C? Okay, so it's minus 92.2 kilojoules per mole. So minus delta H over T, so minus 92,000 over 25 degrees C, so 298. So it's going to be 92,000 divided by 298, which clearly isn't this answer. So presumably it's 309.4 C. Yeah. Still one person forgot to put it into Kelvin there. And finally, potassium nitrate is very soluble in water. The solubility of potassium nitrate increases rapidly with temperature. The best explanation for this is, right, well, we know that delta S system is going to be a positive number, but delta S surroundings, because this is endothermic, is going to be a negative number. So why? What's going on? As you increase temperature, well, this is because delta S surroundings is minus delta H over T, this gets smaller, and so it gets less negative. So delta S surroundings becomes less negative as the temperature increases. Yes, molar entropy of a substance increases with temperature. That is true, but this is a minor effect, barring state changes. Delta S system increases as the temperature increases. Well, we don't know that's true. There are more particles on the right hand side of the equation. We got the water particles on the left, so that's not necessarily true. So it is A. And 60% of you getting that right, but still a lot of you not getting that right. The reason that this is not right is because we know that the molar entropy of KNO3 solid is going up with temperature, but so is the molar entropy of potassium and nitrate, and indeed the waters. And we don't know the relative balance between how much they're climbing, and therefore if this one, the KNO3, is climbing faster, delta S system might get less significant, but if the others are climbing more, it might get more significant. We cannot tell without further information whether or not delta S system is going to increase or decrease. It will change, but we don't know how. Hopefully that was useful. I put the mark scheme on for the rest of the questions, and let me know if there's anything you need before your end of topic test next week. Just make sure, some of you still were struggling to upload documents on a Google form. Your end of topic test is going to be like your end of year test, so you need to get to grips with Google Forms and do it on a proper computer if you're not able to upload photos from a phone. Thank you.